This is Alejandro Cisneros from the group AOT for the final project in CS354R. And the main focus of my project was pathfinding and navigation in a 3D space. So I built this scene out here in Unity. This is the engine of choice I'm using for my final project. I am creating a plugin though for Unity, just like we did in Godot. This is the DLL, and then I'm just bringing out my scripts from here and attaching them to game objects, just like in Godot. But this is my octree testing scene, and as you can see, I just kind of placed a lot of geometry around the scene to see how my octree would divide up given the axis aligned bounding boxes for this geometry. And that's what I did. I created an algorithm to create a sparse voxel octree so that I could run A star on the empty leaf nodes of the octree. That way we could search less nodes overall in the A star pathfinding algorithm compared to just dividing up the world into tons of tiny little voxels. And I'm actually pretty proud of the results. So I'll go ahead and show you really quickly how the octree visualized. So I'll go ahead and press play. I go into my scene view, and this might look like this might be a little hard to see, but I'll go ahead and go over to like this first octant over here, and all the nodes that are highlighted in blue are occupied and they cannot be traversed. So those are non-empty leaf nodes. So you can see, like, for all these cubes over here, the octree decided to divide this octant up for them, and then it saw, hey, we have geometry in these cubes. They are not traversable. They are non-empty. But over here, there is no geometry, and it didn't need to subdivide further. So you can see that this leaf node is it's double the size of these. And so just to see how this is advantageous for the A-star algorithm, you could, if you were pathfinding from this node to, I don't know, let's say you wanted to go all the way over here or something, what you could do is you could go to this leaf node, which is empty. It is smaller. But then you could go from this node to this bigger leaf node, which is larger. And then you could jump to this bigger leaf node, which is even larger. So that's even less nodes to search. And with like a good heuristic, we'll just continue to go through the large leaf nodes until we reach our desired location. So that's that. I'm going to turn drawing off of the entire tree, and I'll just show you a visualization of the A-star algorithm I've implemented for the octree. So given two start position, or a start position and end position, we'll go ahead and pathfind through the octree to find a path from the start to end. And so I'm just using these transforms right here. So we have our path start, this represented by this little cube, and our path end, represented by that cube over there in the distance. You can see it's like, it is, again, this is three-dimensional pathfinding. So it's like we're in the air over here. Our AI is going to be able to fly, and so that is really important for this project. And the really cool thing about this is you can have concave geometry that the AI can traverse. So anyways, let's go ahead and visualize that. So I'm just going to I'm going to run the scene. And we'll go ahead and visualize the pathfinding. And as you can see, we're doing our A-star search through the octree until we get to our end node. And you can see that's the path generated. It's a little ragged because of, like, we're going in a straight line here, but I might add like a path smoothing algorithm to this to make it less ragged if there's time, or even a simple optimization so that AI can just go, like, if you see the end from here, just go straight to the end. And so that's quick pathfinding. So yeah, that's how I'm going to do pathfinding for the AI in 3D space, because the AI needs to be able to, again, fly in any direction. And now for the player controller that I'm currently working on. It's really simple right now. It is physics-based. There is no, the grappling hook part is not implemented yet, but we have basic movement in all directions. You can jump. And then I've already implemented bursting, but there is no effects for it yet. So if you're in the air, you can press WASD, Q, or E to burst in a direction. So if I press E and then E again, I can burst up, Q to burst down, D to double tap D to burst right, double tap A to burst left, double tap S to burst back, and double tap W to burst forwards. And this needs a little refining, but it'll basically allow the player to traverse in all directions relatively easily. And then along with the grappling hooks, it'll make a pretty cool 3D movement system. So while I don't necessarily have like a playable alpha, most of the infrastructure is there. I'm pretty confident I'll be able to complete everything by the deadline. And yeah, got Octree, A-star on the Octree for the AI. I've implemented an FSM for both the player and the AI to use, and I've already started to implement a lot of the player states, as you can see. So that's the current state of the project. Thanks for watching.